This conference will now be recorded.
Okay, so let me do a quick introduction today. So today the topic is to kind of a public review of the NIC software specification that's been out for a while now. I know there's a lot of comments in the community, in the emails and other forums, but this is to solicit live comments and discussion. Um, so not sure anybody particularly has joined for this topic. If so, you can share. But Willem, yeah, maybe we get started on maybe updating the community on what's happened since you last presented in March, I think.
Yeah, that's right. Sounds
and
good.
Then we can see if there's any Q&A after that.
Can I be a presenter? That would
All right. Let me make you the presenter. There you go.
Great, thanks. Let's see. So, all right. Yeah, so since March, this is, by the way, the sort of homepage, the wiki page we have. So all this stuff that I'm sharing, you can also find through there. Notably, the draft offload. This is the biggest change. We've been working on this together for, I guess, about 9 months, or no, a year now. And we finally shared it with the wider community for feedback because the authors, the signatory organizations, are happy with it. I'll briefly go, like very briefly revisit what this is all about. So this was a presentation from March. Okay, this is a presentation from March. I won't go over all of it. I think the most important slide is like, why are we doing this, right? And the idea is that as I work at Google, we also have Meta and NVIDIA and Intel on board. Traditionally, I think conversations between companies that buy a lot of network cards, particularly hyperscalers, and vendors of network cards are very much one-on-one. They are unstructured. They are behind NDAs. And even I think, my experience, even our experience within Google is that it's a whole new thing for every generation of hardware. There's a doc being written that might be imprecise. So we want to get rid of both the busy work that happens with every negotiation, more importantly, the imprecision that happens. So have a common understanding within the industry. What is it that is sort of the table stakes of network interfaces, which means that some of the more advanced things we leave off the table. And we want an open ecosystem, so no NDAs, and describe the features in sufficient detail that we remove ambiguity. I think we've also learned the hard way that some features everyone thinks they agree on how they work, and then it turns out that the implementations have subtle differences, which if you run a heterogeneous environment like we do, is very complicated. As simple as counters that either the list is not standard, whereas we have fleet-wide ingestion of these counters, or more problematic is when the counters exist, but they actually count something different, which often happens with byte counters. So, I mean, that's the level of sort of table stakes we're talking about as well. Goal is to basically have a checklist to say where a vendor can self-certify, say, okay, we implement these features according to the spec. And in the end, negotiations are always still between, a potential consumer and a producer of hardware. So they don't have to follow the spec, but I think the spec is a good starting point where parties can say, we implement this spec with the exception of, point 7.2, where we do something slightly different. If everyone's okay with that, that's fine too. I don't think we're going to be able to write a spec that satisfies every opinion of everyone. We're trying to, satisfy I think the common opinions, and in some points it's fine, particularly for legacy hardware that just works differently, to diverge as long as that's explicitly stated. That's the goal. And part of the self-certification is also that we go out of our way to create a test suite that is all open source software, easily accessible, to allow to actually not just self-certify in terms of, we think it works, but that it's easy to see that it works. And I found that this helps later on when ingesting hardware to work together and to say, hey, this feature doesn't work the way we expect it to work, run this application and see, that it passes on your side. Any questions so far on the goals of what we're doing here? All right, well, in that case, let's go to the draft spec. I shared this on behalf of the four parties who have been writing this probably over about 2 months ago. Here we go, public draft May 18th, and announced it on the OCP networking list. It's a pretty long document. Again, I've gone over what's in it in March, so let's not do that again. But the brief summary describes how current 10 gig, 100 gig, 200, whatever, those modern network cards, how they mostly work in terms of having asynchronous communication over descriptor queues, using like MSI interrupts, having multiple queues. Then we become a little bit more, so that's the basics of pushing packets, but then there are the more advanced offloads where we take a very principled stand and we say we want offloads to be stateless where possible. That's not a controversial stance. I think this point has been made, at least in the Linux community, by multiple people in presentations and over the last 10 years at least. We just reinforce that and give some arguments from our experience why it's so important to be protocol independent and to be stateless. And the stateless argument is really scalability, where we currently have machines that handle 10 million connections, TCP connections. So anything that scales O1 with connections is almost certainly going to be a headache because we're going to run out of hardware resources. The protocol independence is because protocols keep changing, both in public space, but even more so in sort of walled gardens, such as hyperscalers. So we don't want to be beholden to, oh, this only supports, at VXLAN, not your custom extension to VXLAN, for instance. So we go over the standard offloads, which if you look closely enough are not that standard. There's a lot of ambiguity there. Checksum offload, segmentation offload, receive segmentation, coalescing, which is the batching packets that come into the machine into bigger packets. Traffic shaping is very important, quality of service at scale. Timestamping is increasingly very important, so we did include that in this first version of the spec. The protocol section is not that large, I think. It's things to what MTU should be supported, what do we think about what are the requirements for MPLS, VLAN, and such. And then we get to the, I think, sort of interesting part. So telemetry is not the interesting part yet, sorry. That's the counters that I mentioned before, that some counters are standardized at the link layer, but a lot of them aren't. The performance section is interesting, I think. We start in the introduction by describing the workload that we target, right? And the target here is very much hyperscale or warehouse scale computing. I think a lot of this applies to other large deployments, maybe telecoms and so, but they might be, somewhat different. Like, so we mentioned the scale, the connection count, we have the connection rate, that it's a mix of workloads. And then in the performance section, we actually say, well, what is actually expected of a network card? Like most network cards out of the box come with one number, which is it's 100 gig NIC. What does that really mean in terms of the bit rate, which is the advertised one, once you start taking into account these features, once you start taking into account things like MTU, also, what are the other expectations we have on being able to push a single flow, being able to handle, reach these limits in a real world environment where there may be contention. What's the packet rate, which is a pretty obvious one. It doesn't necessarily mean line rate at small packet sizes once we're talking about 400 gig NICs. And a few others, connection count, we mentioned latency. Then we get to the appendices, which are, the Appendix A is, I think, the most important one. It is a very brief summary of everything that's in these like 40 or so pages of text. The requirements of the individual features as a simple checklist. And any vendor can basically look at their hardware and say, does it meet these requirements or not? It's a checklist. So you can see there are actually three. There's a column here, required, which is basic, advanced, or optional. There is a basic level, which we really consider table stakes, and I think most NICs today just match. Then there is an advanced level, which is what Meta and Google both, two of the authors of this spec, essentially require. We think that this is the interesting part, but we are aware that not every NIC will support this. So when we put out a request for hardware, it will be the advanced format. And then optional are features that aren't implemented very often. They are either an individual party's preference, or they are something we believe that is useful going forward, but it's too early to make those strict requirements. There shouldn't be many optional ones. Things like, oh yeah, accelerated RFS, ARFS here is a good example of a feature that exists that we actually don't care about, but if it's going to be implemented, it should be implemented in a standard, well understood way. So that's why it's an optional feature, but the feature is described hopefully in an unambiguous form. Okay, so that's Appendix A. That's, I think, the important one, the way we communicate or plan to communicate with each other. Then there's a validation section, how to validate that the hardware conforms to the spec using whatever open source software exists. The control is basically Linux. The spec isn't Linux specific, but we use Linux, so that's what we take for our testing. The control part is essentially standard Linux tools, and the functional part, there are a bunch of tests that made it into upstream Linux, such as testing for RSS, testing for what is this, header split, checksum offload, TCP segmentation offload. There are features that are the tests for which are not in upstream Linux yet. A few of those are on GitHub. So for instance, this tstep one. And for performance, we basically come up with a matrix of performance tests using there's standards like NetPerf, NetPerf, iPerf are very popular. At Google, we've developed NetPer a long time ago, which more closely matches, I think, our application workload at least. It's like the short version of NetPer is that it is NetPerf, but it internally supports multiple flows, multiple threads, and aggregating statistics over those, which is essentially essential these days. So we test number of streams, number of request responses, TCP, UDP, connect request response, which is essentially scalability with connection rate, and then what metrics are interested. All right, so this is a very long overview. Oh, and it is actually worth pointing out, looking at other OCP specs, we see that the specs have revisions. So the OCP NIC 3.0 is a NIC, but the spec itself is actually minor revisions in there. We expect the same will happen here. So the goal is really to we already have features that we want to standardize, particularly crypto offload. The goal is to basically make this a document that gets revised maybe every 1 or 2 years. We'll discuss that. And if there are smaller changes, errors, clarifications, such, we can create a minor update maybe every 3 to 6 months. So the first revision is actually all the way at the top, which is based on the public feedback. So first of all, thanks to everyone who took the effort to skim or read this document. It's pretty long, and to give us feedback. It's very insightful. Some of it was our just bias we have. I think some of it was unclear writing. So I think the doc has improved. These are all the changes we made. I don't think we should go over all of them. I'll point out that there is one item really still open, which is to do with RSS and fragmentation, and a smaller one, RSS and flow hash, that will resolve. We can do it here if the right people are in the meeting, and otherwise we'll do it after. I really scheduled this session to also have a way for people who read the doc or have comments to be able to do that live. So I'd like to, hand the mic to whoever has comments or questions about the spec.
Thank you, Willem. I had a question. So the public draft is a wiki page, right? So how were the comments? Were they just on the wiki, or were they in a Google Doc, or were they email?
I shared the spec initially the draft as this Google Doc that you see here. And I later copied it and put it in the wiki so that it would also be easy to find through something like Google search. But the one that has the changes is the Google Docs. And in the announcement email to the OCP networking list, I believe I shared both. I also made it clear that comments can come either in the form of an email to the mailing list, which, for instance, Tom Herbert did, or as comments in line in the doc, and then whoever wanted to give comments would just have to ping me to give them comment access. I was a little bit concerned with the public doc of like vandalism, so I needed to just add you as a commenter, and I think we've had 4 people or so comment on it.
Sure, thanks.
I've resolved all the comments now. When I edited, I resolved them, and I made this summary at the top of what these comments were. And I hope I resolved them correctly. So that's another reason we're having this session. If I resolve the comment, he's like, no, you did that wrong. Now's the time to tell me.
Yeah, thanks. Well, anybody has questions, please go ahead.
I see.
This is quite good. It's a very good effort. I like the foundations of it. One question is, have you guys considered customization? Because that's kind of an interesting topic that's going around right now.
Customization, can you give an example of the kind of customization we'd be looking for?
Well, I mean, there's like layer 3 customizations and maybe even 5-layer customizations. I mean, there's different, different guys are looking at doing different things, and they're talking about it in the industry. So this has raised everyone's awareness that, hey, maybe we want to do this too.
We gave it a little bit of thought that there's no one spec will satisfy everyone, nor that is the intent, right? That again, when we put out a request for a new 400 or 800 gig NIC, we might have very specific needs that are not even covered by the spec, or we might be willing to accept a NIC that just deviates from the spec. So I think the goal of the checklist is to have a starting point. And it's pretty easy to say we don't implement this feature, or we implement this additional feature. And particularly, I hope that additional features will be added, contributed to the text. So in that sense, I think the goal is not to have a one size fits all, and individual hardware can differ from what's here. Does that answer the question?
Yes, it does. Thank you. So this is going to be a base spec, right?
Yeah. The goal is for this to actually stop presenting soon. The goal is for this to be a starting point for these conversations between vendors and hardware and users of hardware, to avoid every conversation starting from scratch with an empty document that people fill in like a whirlwind, and repeatedly miss like common things that should be there.
Yeah, this is a great goal. And I haven't actually looked at the document, but when you're talking about validation, that validation is only for the layers, right? The networking layers. It's not really about any type of higher level thing, right?
It's actually, it is essentially how we do a lot of our validation today and in previous generation of NICs that we've ingested. It is a combination of verifying that the features exist, which is a control operation. Often you can query that, verify that the features work as intended, which requires creating sometimes fairly complicated tests, things like RSS, which does load balancing based on a particular hash function. Verifying that the hash function is implemented as intended is not entirely trivial. Checksum has its weird quirks in terms of the example I've been given all the time is a common one is that UDP can have a zero checksum, meaning no checksum is present. And then a checksum present with all zeros needs to be all apps. All these kind of things we have software Linux-based tests for. I think the most complicated to get right are performance-based tests. I mean, we struggle with that. In general, we have within Google, for instance, our own matrix of tests. And every time we upgrade our Linux kernel, we verify that we don't regress on things like 1,000 concurrent TCP connections because we know our applications will, some SRE will complain loudly and rightly so if we do regress. But those performance tests can be very sensitive to noise in the background. So it really is what we have here. I think would say a first pass of getting that done. Google is one example. I think pretty much every organization has these kind of performance matrix based on IPER for NetPer for NEPR, and not having to come up with those from scratch, but hopefully getting that in GitHub as a shared resource would be a good step forward too.
Thank you. I'm impressed.
Thanks.
Yeah, I'll say I agree. Like it's a really good detailed document, kind of setting expectations with use cases, and I particularly like the validation suite. So giving people a way to say, if you're using Linux, here's some commands, run this, make sure you're meeting what we expect.
Yeah, thanks a lot, David. I think I have to be clear that the validation section is a work. It should be considered a work in progress always.
All of it's a work in progress, right? I mean, yeah.
Yep. All right.
Right.
Other questions or comments on it? Else, my proposal is to go with this to the OCP incubation committee and ask to basically get the first version as an OCP spec, and then we'll continue the development in the same process we had, but now we can do it in the open for revision, so it'll be easier for others to contribute, basically patches to the text. As I said, there's from the start we made it clear that we're also interested in crypto, specifically PSP, although that I think is our meaning Facebook and Google's interest, or Meta and Google's interest. Other crypto protocols should also be covered, so that would be probably the first extension to this work.
Right. I don't see any other questions. So I had a question. How do you imagine further contributions along this track? How would we encourage those?
As long as we keep developing in the open, meaning we send updates to the OCP networking list, hopefully that will remind people that this is here and they can contribute, and also as organizations use this in their public conversations. I think like this year we're not presenting an OCP Global Summit because I think the talk wouldn't have been very different from last year in terms of features. It's just a lot more concrete. But that's another venue, the OCP community, to request contributions. Also, we're very interested in more vendors and more users to contribute, including users with a different viewpoint from hyperscalers. So we'll continue to work on it and send updates publicly. I think that's a start.
So when do we expect vendors to start validating and contributing to the spec?
The validation is, I think, twofold. It is if you're working with a potential buyer of hardware and use this spec as a basis, then I think that's where the validation definitely comes in. And once you do the work of running the validation and essentially working through the checklist, I would encourage a vendor to then make that also public, right? You can only really say we publicly adhere to the spec once the spec is ratified by the OCP, but hopefully that won't take too long. And then either immediately make it public once the OCP spec is there, I could make an announcement, or by working with the first user when you get around to it, basically. That's the validation part. The contributing, well, obviously, you know, NVIDIA is one of the contributors, so we can work right now. I think when we got started on this, I had to learn how to work with this in the sort of legal sense. So right now, only the signatories, which is Meta, NVIDIA, Intel, and Google, can directly contribute, can directly edit the text. But I've repeatedly in talks also encouraged others to send us changes, and we can incorporate them. I think this issue of signatories have to actually sign the spec is a bit of a hurdle, potentially for someone who or an organization only wants to make small contributions. So then essentially we become the editors, and contributions go through the mailing list, and you know we accept them as we see fit. But it is even if it's not as standard yet, it is public. So right now, any contributions I think are welcome.
So what's missing to me here is how do we intend to expose more users to the spec so it will give, like, encourage vendors to use it as a baseline of compatibility and validity.
Okay,
Yeah.
that's a fair point. I've really only used OCP as a venue to attract attention and to request organizations to be involved. So the Global Summit and also the tech meetings in spring are a good venue, and the OCP networking community itself. Maybe I think now that we're this far and it's public, we could actually share it elsewhere in the Linux community. Is potentially since a lot of the users are there, and I guess I'm open for other suggestions of like good venues to announce this, to request.
If you guys send the foundation team, send us a reminder, we'll broadcast it on our social channels, right? And we'll kind of amplify through the reach that we have of everyone that's connected to OCP, so that at least within the OCP community, that you know the word goes out, and plus it goes beyond that too, right? Like through LinkedIn and all the socials. So if you guys do that, we'll be happy to promote it to get as many people as we can to get involved.
Great, thanks. Okay, we'll do that. I guess when it's the standard, right? That's the right time, I guess, to do it. Yeah.
Yeah, probably after your IC meeting, you know, after the voting period or whatever, we can synchronize and have it, you know, ready to go out at that time.
Great. Saeed?
Yeah, I would also recommend reaching out to the NetDev conference community, and maybe Linux plumbers, maybe have a session there, explain what's going on.
Okay. That's an interesting point. I mean, I know both of them are coming up. Linux plumbers and NetDev. I guess most of it is conversations are really about Linux kernel code. But yeah, I'll take another look.
Yeah.
All right. Yes, thanks everyone. Indra, I think you're muted.
Yeah, sorry. Yeah, I was wondering if there's any more questions. But yeah, that is a good point about expanding the outreach. All right, but yeah, if there's no other questions, I think we can have some time back to ourselves. And thanks, William, for presenting, and more importantly, like shepherding this through for the whole year. It's a lot of work. I know there's been behind this, so
Thanks. Once again, also thank you for David and everybody else who reviewed it, bothered to read it, and give insightful comments.
Yeah, I'd say thanks to your work on this as well. Like, I'm sure it takes a lot of your time and the other editors to go through and write all this down from the perspective of what each company is looking for. So
it was honestly, yes, but it was also somewhat cathartic to finally get it written down in a way that I hopefully don't have to think about it anymore next time we have these conversations.
yeah, and some of your validation tests, I went through your repo and was looking at some of those test cases. I mean, that takes a fair amount of time as well, just to prove out the APIs and how things are supposed to work. So yeah, thanks for that.
Cool.
thank you. Have a good day, guys.
Thank you, guys.
Bye bye.